Potential difference, also known as voltage, is a fundamental concept in physics and electrical engineering. It refers to the difference in electrical potential energy between 2 points in a circuit, which determines the direction and magnitude of the flow of electric charge between those points. In simpler terms, it is the energy required to move an electric charge from one point to another. The concept of potential difference is central to the understanding of many electrical phenomena, including current flow, resistance, power, and capacitance. It is also a crucial factor in the design and operation of a wide range of electrical devices, from batteries and power supplies to motors and generators. Potential difference is measured in units of volts, which are defined as the amount of potential energy required to move a charge of 1 coulomb between 2 points in a circuit that have a potential difference of 1 volt. This unit is named after Alessandro Volta, the Italian physicist who invented the first electric battery in the late 18th century. The potential difference in a circuit can be created by a variety of sources, including batteries, generators, and solar cells. In some cases, it may also be produced by the motion of charged particles through a magnetic field, a phenomenon known as electromagnetic induction. Overall, the concept of potential difference is essential for understanding how electricity works and how it is used in everyday life. Whether you are powering a light bulb or charging your phone, potential difference is the driving force behind the flow of electrical energy that makes it all possible. There are several ways to generate potential difference, which is also known as voltage, in a circuit. These methods involve the conversion of one form of energy into electrical energy, which can then be used to power various electrical devices. Some of the most common ways to generate potential difference are as follows. Chemical reactions. This is the most common method of generating potential difference, and it is used in batteries. In a battery, chemical reactions take place inside the cell, producing a difference in electric potential between the terminals of the battery. This potential difference drives the flow of electrical current through the circuit. Electromagnetic induction. This method is used to generate potential difference in a coil of wire by moving a magnet through the coil. The changing magnetic field created by the moving magnet induces a current in the wire, which produces a potential difference between the two ends of the coil. Photovoltaic effect. The photovoltaic effect is used to generate potential difference in solar cells. Solar cells convert light energy from the sun into electrical energy, which can be used to power electrical devices. When photons from the sun strike the solar cell, they are absorbed by the semiconductor material, creating a potential difference between the two ends of the cell. Thermoelectric effect. This method is used to generate potential difference by converting thermal energy into electrical energy. The thermoelectric effect is based on the Seebeck effect, which is the creation of a potential difference across a temperature gradient. This effect is used in thermoelectric generators, which are used to generate electricity from waste heat in industrial processes. Piezoelectric effect. This method is used to generate potential difference by applying pressure or stress to certain materials, such as quartz crystals. When pressure is applied to these materials, they produce a potential difference across their surface, which can be used to power electronic devices. Electrostatic induction. This method is used to generate potential difference by using charged objects to induce a charge on another object. For example, rubbing a balloon on a wool sweater can generate static electricity, which can produce a potential difference between the balloon and other objects. In conclusion, there are several ways to generate potential difference, including chemical reactions, electromagnetic induction, the photovoltaic effect, the thermoelectric effect, and static electricity. Each of these methods has its advantages and disadvantages, and the choice of which method to use will depend on the specific requirements of the circuit or device being designed. Potential difference, also known as voltage, has several key characteristics that make it a fundamental concept in physics and electrical engineering. Some of the most important characteristics of potential difference are: direction. Potential difference has a direction, which is determined by the relative positions of the 2 points between which the potential difference is measured. The direction of potential difference is from the point of higher potential energy to the point of lower potential energy. Magnitude. Potential difference is measured in volts, which is a unit of electrical potential energy. The magnitude of potential difference is determined by the amount of electrical energy required to move a unit of charge between the 2 points. Polarity. Potential difference has polarity, which refers to the sign of the voltage at each point in the circuit. The point of higher potential energy is said to have a positive voltage, while the point of lower potential energy is said to have negative voltage. Energy transfer. Potential difference is the driving force behind the flow of electrical energy in a circuit. When there is a potential difference between 2 points in a circuit, electric charge will flow from the point of higher potential energy to the point of lower potential energy, releasing energy in the process. Relationship to current. Potential difference and current are closely related in a circuit. In general, the greater the potential difference, the greater the current flow in the circuit. This relationship is described by Ohm's law, which states that the current flowing through a circuit is directly proportional to the potential difference and inversely proportional to the resistance of the circuit. Overall, potential difference is a critical concept in the study of electricity and electronics. Its direction, magnitude, polarity, and relationship to current all play important roles in the operation and design of electrical circuits and devices. It's important to note that potential difference, also known as voltage, is a fundamental concept in electrical engineering and has numerous applications. Therefore, the advantages and disadvantages of potential difference depend on the specific application and context in which it is being used. However, some general advantages and disadvantages of potential difference are: advantages. Enables the transfer of electrical energy. Potential difference provides the driving force that enables the transfer of electrical energy from one point to another. This is essential for the operation of a wide range of electrical devices and systems. Allows for precise control of electrical systems. By adjusting the potential difference across a circuit, it is possible to control the flow of electrical energy and regulate the behavior of electrical systems. This enables precise control over the operation of devices and systems. Can be generated from a variety of sources. Potential difference can be generated from a variety of sources, including chemical reactions, electromagnetic induction, the photovoltaic effect, and the thermoelectric effect. This versatility makes it possible to generate electrical energy in a wide range of contexts and applications. Simple to measure and monitor. Potential difference is easy to measure and monitor using standard electrical testing equipment, such as multimeters. This makes it easy to diagnose and troubleshoot electrical problems. Disadvantages. Can be dangerous. High levels of potential difference can be dangerous and even lethal, particularly if proper safety precautions are not taken. This is why electrical systems are typically designed with safety features, such as fuses and circuit breakers, to prevent electrical accidents. Potential for electrical interference. Potential difference can also lead to electrical interference, which can disrupt the operation of electrical devices and systems. This is particularly true in environments with high levels of electromagnetic interference, such as near radio and TV transmitters. Requires specialized equipment. In order to generate, measure, and regulate potential difference, specialized equipment is often required. This can make electrical systems more complex and expensive to design and operate, dependent on external factors. The generation and measurement of potential difference are often dependent on external factors, such as temperature and humidity. This can make it difficult to maintain consistent performance in electrical systems over time. In conclusion, potential difference has numerous advantages and disadvantages depending on the specific application and context in which it is being used. While it provides the driving force for the transfer of electrical energy and enables precise control of electrical systems, It can also be dangerous, lead to electrical interference, require specialized equipment, and be dependent on external factors. Potential difference, also known as voltage, has many applications and uses in various fields. Some of the most important applications of potential difference are electrical power generation. Potential difference is used to generate electrical power in power plants, where turbines are driven by steam or water to create a potential difference across a conductor, thereby generating electrical energy. Electrical circuit design. Potential difference is a fundamental concept in electrical circuit design. By controlling the potential difference across different parts of a circuit, engineers can regulate the flow of current and voltage and control the behavior of electrical devices. Battery technology. Batteries rely on the potential difference between two electrodes to generate electrical energy. By controlling the materials used in the electrodes, engineers can create batteries with different potential differences, which can be used for various applications. Electronic devices. Potential difference is used in a wide range of electronic devices, such as computers, cell phones, and televisions, to power and control their functions. Medical applications. Potential difference is used in various medical applications, such as electrocardiograms, ECGs, and electroencephalograms, EGs, to measure the electrical activity of the heart and brain. Chemical analysis. Potential difference is used in analytical chemistry to separate and analyze different chemical compounds based on their potential differences. Lighting. Potential difference is used in lighting systems, such as light-emitting diodes, LEDs, and fluorescent bulbs, to create the necessary voltage to produce light. Renewable energy systems. Potential difference is used in various renewable energy systems, such as solar panels and wind turbines, to generate electrical energy from natural sources. Overall, potential difference is a critical concept in the design and operation of various electrical and electronic systems. Its applications and uses are broad and diverse, making it an essential tool for engineers and scientists in many fields.